Hi, I'm Chloe Caux-Wetherell, EMEA Marketing Manager at DuPont Personal Protection.
And I'm Aldjia Begriche, Global Technical Manager at DuPont Personal Protection.
So today, we would like to share with you some insights on how to enhance worker well-being while wearing a chemical protective clothing, specifically in light of a recent product introduction, Tyvek APX. Worker well-being and comfort have gained increased prominence in recent years as companies across sectors from pharmaceutical and utilities to heavy manufacturing and chemical processing have placed an increased focus on worker safety. A key focus area regarding comfort is the ability to efficiently dissipate body heat while wearing protective clothing, which is crucial for ensuring worker comfort but also preventing overheating. Globally, regulatory bodies and health experts are recognizing this link by placing more emphasis on worker well-being. We see decrees being released in different countries, but also more requirements to back comfort claims with data. This is a very positive shift, changing the way we think about comfort, not only subjective, but also becoming measurable. So Tyvek APX was developed in this context to enhance worker well-being, as this ultimately leads to increased safety. It's a new type of Tyvek fabric that is extremely breathable while maintaining the legacy protection and durability of Tyvek. It was developed after years of collaboration with our customers, observing their daily challenges, but also intense scientific research to make garments more breathable without sacrificing performance or durability.
When we talk about breathability in protective clothing, everyone uses the word, but not everyone means the same thing. That's why the Hohenstein classification is useful. It gives the industry a common language to describe how breathable a fabric or garment really is. The Hohenstein Institute created a classification table that groups fabrics into breathability levels, based on objective laboratory measurements, mainly the water vapor resistance, commonly called RET. RET tells us how much resistance a fabric creates against sweat evaporating from the body. The lower the RET value, the easier sweat can escape and the more comfortable the garment feels. Hohenstein classification has 5 levels, from not or barely breathable for fabrics with a RET of above 20 to extremely breathable for fabrics of a RET below 6. At the highest level, resistance to moisture transfer is very low. These garments actively support thermoregulation and significantly help to reduce heat stress. In the case of Tyvek APX, we have developed a new type of Tyvek fabric that is extremely breathable, allowing enhanced moisture evaporation and improved air circulation. These properties have been scientifically validated by independent laboratories, including EMEA, where we have conducted a comfort evaluation as a progressive journey, moving from predictive science to real human response, with the objective to quantify comfort not as a subjective claim, but as a physiological outcome that can be predicted, measured, and validated. First, we used a validated human thermoregulation model to simulate how the body responds when wearing protective clothing. By combining fabric properties, garment design, activity level, and climate, we predict changes in core body temperature, skin temperature, sweat rate, and thermal strain. Next, we validated these predictions through controlled human wear trials. Participants wore the garments in a climate-controlled environment while we measured real physiological data along with perceived comfort.
In addition, we conducted customer wear trials globally to gauge whether wearers could feel the difference in performance. Many wearers took part across different regions and applications. The garments were tested in extremes of temperatures and humidity, and from low work intensity to high levels of activity.
The simulations show that Tyvek APX protective coveralls lead to a slower rise in core and skin temperature, helping reduce physiological heat strain under demanding conditions. The human trial results confirm the simulations. Wearers experience lower physiological strain, reduced sweat response, and improved comfort compared to traditional protective garments. We also learned that perception is critical. If individuals find the protective gear uncomfortable, it can negatively impact their mental state and well-being, ultimately affecting their performance and safety. For instance, people are highly sensitive to skin wetness. Once it reaches a certain point, discomfort sets in rapidly. Wet skin makes garments feel heavier and stickier, reducing comfort and potentially impacting performance and compliance. Reducing skin moisture helps regulate body temperature and keeps garments feeling drier and more comfortable over time. Tyvek APX has demonstrated a remarkable ability to efficiently transfer water vapor from inside the garment to the external environment.
So looking ahead, there is an opportunity to adopt a fresh perspective on comfort. Historically, comfort has often been evaluated based on anecdotal evidence, relying on subjective feedback from operators. While such feedback is very valuable, safety managers can now also access evidence-based rationale for reducing physiological strain. Furthermore, comfort has traditionally been viewed as a trade-off. Increased comfort has often meant reduced protection, and more protection, less breathability, leading ultimately often to heat stress or unsafe wear practices. However, there is now a shift in this paradigm. It is possible to achieve extreme breathability while still benefiting from proven protection and durability.